Welcome to Academica Lab Solutions. FOL-CWDM, Coarse Wavelength Division Multiplexing and Add Drop of Channel. FOL-CWDM is a benchtop module enabling the students to implement CWDM and demonstrate the functioning of add drop of channel in optical networks. This module has 4 DFB lasers of different wavelengths with channel separation of 20 nanometers as per ITU standards like 1510 nanometers, 1530 nanometers, 1550 nanometers and 1570 nanometer. It also has a 4-pin photodiode detector, 4-channel 4:1 mux demux, fiber Bragg rating with reflection at 1550 nanometer, a 3-port polarization independent optical circulator for C plus L band. This module is interfaced with the PC via USB and a user-friendly GUI allows to control parameters and display results. Facility for source modulation using internal test signal as well as external user-defined signals are also available. CWDM using internal modulation signal. Switch on the system and connect the USB cable to the PC. Launch the FOL-CWDM software on the PC and select the correct COM port. The laser power supply is switched on. Connect the individual laser sources to the respective MUX input ports. MUX output is connected to the DMUX input and the demultiplexed output is connected to corresponding detectors. Now, select the modulation mode in the software. Also select all the laser sources and the internal modulation mode on the software. For each wavelength, select an internally generated digital signal using the drop-down arrow and keep the slider to any value above 80 units. Then, click the Run button. Now, you will be able to transmit and receive signal at respective receiver channels. Optical Add Drop of Channel (OADM). Now let's understand the concept of OADM, Optical Add Drop Multiplexing, using our FOL-CWDM module. While transmission, there might be a need to add or drop one channel or wavelength and route it to another location. This is where we use OADM. OADM is a combination of a 3-port circulator and an FBG with a central wavelength equal to the wavelength that needs to be dropped, in our case, FBG at 1550 nanometer. Dropping of channel. The multiplex signal coming from a different location consisting of wavelength 1510 nanometers, 1530 nanometers, 1550 nanometers and 1570 nanometers is given to the circulator port 1. The circulator will transmit to port 2. The port 2 of the circulator is given to the input of the FBG. Since this FBG's central wavelength is at 1550 nanometer, it will reflect 1550 and come as input to port 2 of the circulator, which in turn will be transmitted to port 3. This is where you can receive the dropped wavelength or the channel. Adding of channel. The multiplex signal that is coming from a different location reaches port 2 of the circulator through the FBG. This MUX signal will reach port 3. The wavelength 1550 nanometer that needs to be added is given to the port 1 of the circulator. Also, the 1550 nanometer signal reaching port 2 gets reflected back by the FBG and will pass to port 3 of the circulator, and thus will add up to the multiplex signal. Hence, at port 3, we will receive the MUX signal plus the added wavelength or the channel. Thank you.